All right, good morning. You guys hear me OK? OK, awesome. So my name is Manasi, and I am the CEO of Verta.AI. I also built a system called ModelDB during grad school that I'm going to be talking about today. And the topic that I want to discuss is one that I think I've heard a lot of people at the conference mention multiple times, is how do we make our data science workflows more efficient, and how do we streamline it? And throughout my work at MIT, and now with Verta, we think that model management, and particularly managing the lifecycle of the model, is the way to do this. All right. All right, quick background. So did my PhD work in computer science on tools for data science and machine learning. I also used to be part of the data science and ML teams at Twitter and Google, worked on feed ranking, ad targeting, things like that. And then ended up building a series of tools to help data scientists better manage, debug, and also visualize their models. OK, let's dive in. So there's 3 things that I would like you guys to leave with at the end of this talk. The first one is, when you're thinking about production data science or machine learning, we found that 4 things are key. The first one is reproducibility. The second one is reuse. Third, time to delivery. And fourth, reliability. I'll go into each one of these over the course of my talk. Next, we believe that model lifecycle management is the key to streamline data science. And MLM is not a single tool. It's more like a set of practices and processes that are going to enable efficiency in data science. And finally, I'll show you a few tools that make it easy to do the right thing as you're building and deploying models. So everyone here can agree that enterprises have made large investments in data science and machine learning. It's probably your company. It's research labs. It's everywhere. The challenge, however, is that we have some key issues we need to fix before we can entrust these models to make key business decisions. And I'm going to give about 4 examples of challenges that we have seen in this space. The first one is that we can't track our models. As much as we would like to think we can, not really. These are exact comments from a Kaggle notebook. This is a top Kaggler. And the best that this person can do is write 3 lines of code to explain what changed between different versions. Imagine a software engineer having to do this every time they push their code or like made a little change. It's not efficient, and it's not scalable. The second problem is that of sharing data science models and knowledge. And for this one, I'm going to draw upon a personal anecdote. So I spent a bunch of time doing social media feed ranking. And one of my main projects was tuning the feed ranking models. And when I got there, my boss was like, OK, here's the model. Here are the 4 hyperparameters. Go figure it out. I'm like, OK, we already have certain values for these hyperparameters. Where did they come from? And the answer, as you might imagine, is someone worked on it. They left the company. We don't know. It's like, go figure it out. This person already spent a month or 2 months fixing all of these hyperparameters, and now I was just redoing a bunch of their work because we didn't have good records or a mechanism for sharing this information. The next problem that we've seen a lot is bespoke tooling, especially for model deployment, leads to huge time delays. So models took on average 8 to 12 weeks at Airbnb to deploy before they had ML infrastructure in place. Lastly, we find that test data looks very different from training data. I don't know how many people remember Tay, the chatbot from Microsoft. So it started off as this curious and polite chatbot that was going to learn from the internet. And a few days on Twitter, and it turned into something that was abusive and throwing around racial slurs. Clearly, we need to be a lot more responsible when we're putting our models out there. So the sum total is, before we put our business decisions in the hands of models, we need to make data science and ML workflows a lot more robust than they are. So we started working on this at MIT. And we were really motivated by making models reproducible. Our key observation was that model development is iterative. I don't think anyone here has built like the first model and it has worked great. It's a rinse and repeat. I tried something, the accuracy was all right, I changed something else, I keep going. Here are some stats again. On Kaggle, if you look at the top competitors, you'll find that they submit hundreds of models before they get to the top spots. And you might say that Kaggle has strange incentives for people getting to the top. But even at Twitter, when we were pushing a major change to the feed ranking algorithm, we built hundreds of models. It was just how things work. However, we still did not have a reliable way to keep track of the models or the metrics. How can I go back and tell my boss or colleague why I picked one model over the other? How can I track how long a model took to execute in real time? So what we decided to do was we built ModelDB. It is a model database, as you might imagine. We track models during training. We decided that asking data scientists to change their workflow wasn't quite the right way to integrate versioning. Instead, we introduced a way to log the essential elements of a model as people were doing their modeling. So here you can log a data set. You can log hyperparameters, metrics, and models. Hopefully you guys can read that. If not, we have a booth, and all of the stuff is out there, so check it out. All right. So we can log various pieces of information from the API, and then we can visualize it in our dashboard. So this is the older version of ModelDB. I'm going to demo a newer version very shortly. But essentially, we gave people a way to get visibility into all of the models that they were building and run meta-analyses on them. The best thing that we learned from ModelDB was that everyone wants this. We released this in open source. Being a research project, we didn't really go out there and try to get customers, but we got a ton of clones, stars, and forks. We also had Fortune 500 banks and insurance companies using it because they were building so many models and did not have a central repo to keep track of them. To summarize this part, the things that we learned from ModelDB were as follows. You got to standardize the data you want to log. When you say that you're logging a model, what do you mean? Do you mean the code? Do you mean the data? Do you mean the hyperparams? Do you mean the owners of the model? You need to have a standard schema so that multiple people can speak the same language. We also learned that it was important to be minimally intrusive for the data scientists. We can't force them to use a different tool or move away from scikit-learn and NumPy and TensorFlow, things that they love to use. And finally, visibility is key. We can do all of this work on the server side, but if there isn't an easy way to visualize it, say a Tableau-like interface on top of model information, it's a lot harder to consume. So ModelDB was super fun. It's currently also integrated into Kubeflow for folks who are familiar with the TensorFlow on Kubernetes ecosystem. But we learned a really important thing there. Models on laptops don't drive value. Deployed models do. So we're not in the world where I got a model 99% accurate, but hey, you can't deploy it. It's not going to get me any revenue. It's not pushing out new products. It's not getting me any consumers. So then we started looking at, can we extend the concepts from ModelDB to the wider end-to-end lifecycle for our models? And we did that by talking to a whole bunch of people and also learning from how large companies have implemented ML infrastructure. For example, if you look at Airbnb, they have a system called Big Head. When you go through why they implemented the system or their design decisions, a few commonalities start popping out. New teams struggle to use ML. Our workflows are slow, fragmented, and brittle. Google says that reliably producing models is hard. And when data changes over time, like in the case of Tay, you're in a lot of trouble. Finally, glue code and custom deployment scripts don't work for anybody. Uber, with their Michelangelo system, also found a similar set of things. So what we did was we distilled all of this information and conversations with hundreds of data scientists into what I earlier described as the 4 pillars of production data science and ML. They're as follows. You got to be able to reproduce any result. Imagine you were pushing a website and you could not go to a previous version. We would be out of a job. So we got to do better there. The second one is reuse. A lot of the models we end up building, whether it's propensity scores or deciding whether to give someone a loan, we're reusing a lot of the features and the models that others have built before. And it's a lot more efficient to use them as opposed to reinvent them. We also found that time to delivery is key. Again, having a model that's 70% accurate, but you can give it to me tomorrow, is way more efficient than a perfect model 6 months from now. So we need to really emphasize the time it takes to get a model to production. And finally, reliability. Once the model is out in the wild, we got to make sure that it's doing the right things and have alerts or retraining schedules in place so that we can immediately respond to any changes in the environment. The cool thing about these 4 pillars is that they have parallels in code. So software has actually solved some of these problems. Think about Git and SVN. Think about GitHub and GitLab for finding other people's code and reusing it. Things like containerization, CI/CD, have rapidly reduced the time to delivery. And finally, none of the large companies would be working without New Relic, AppDynamics, or PagerDuty, things that monitor how things are going and alert you if something goes down. What about models, right? When we're going to be counting on these models to make key decisions, we need to build out a similar stack here. The other thing that's different about models versus code is that the model lifecycle is super complex. It's not that you write a piece of code and you're good to go. We're doing data prep. We're doing feature engineering. We're doing training, deploy, and monitoring. And at each one of these stages, we have a suite of tools we could be using. Whether you're in a data warehouse, you're using Oracle, MySQL. For feature engineering, you might be using Spark or Pandas. You could be using Dask. For training, there's a host of frameworks. Deployment can be in cloud, on-prem. And for monitoring and logging, again, there's a host of tools. So as we think about making this end-to-end pipeline robust, we need to think about how can we standardize each one of these pieces. And that's where we introduce the concept of model lifecycle management. This is the entire lifecycle, and a break at any one of these stages is going to have pretty bad effects downstream. So we define this concept of lifecycle management as follows. It's a set of practices and processes to support production ML. And the kinds of things you do are the following. Version your modeling artifacts at every stage. Whether you're talking about your features, you're talking about your models, or your containers running the models. Standardize schemas. This sounds really boring, but this is probably the most important thing you can do. If someone's building a model, they need to be using some sort of template, and they need to be storing data in a particular way. We need to make the handoffs between stages uniform. So if you're going from training to deploy, the deploy step should know what the training is going to produce. Similarly, training needs to know what the feature prep is going to produce. Once a model is deployed, we want to know how it's performing at all times. We also want to ensure that the online and offline data is consistent. And finally, coming back to the point of visibility, we want to make sure that we provide a central dashboard or a central view into all data science capabilities with proper access control. So that's model lifecycle management. It is meant to be an abstract set of rules and processes for folks to adopt and make their own. So what kind of tools are available, right? These are processes, that's well and fine. How can I implement it in my day-to-day work? So with ModelDB, we focused on this one piece, which was train. At Verta, we're focusing on the entire pipeline. We're doing the same things that we did at ModelDB. We're standardizing the interfaces. We're tracking metadata at all of these stages. And we're making the handoffs very, very easy. All right. Instead of me talking some more about Verta, I'm going to do a live demo. And the demo gods be with us today. So we'll see. All right. The demo is sort of it covers a lot of ground, so let me situate it a little bit. I'm going to be starting with a Jupyter notebook where we've installed our Python libraries. That library is going to go talk to the ModelDB versioning server that's within the Verta platform. We're then going to go to the Verta dashboard, explore around, build a few charts, make sure that things look OK. We're then going to go and we're going to deploy a model, one of those that we logged earlier. Once that's deployed, we're also going to go and monitor it with no extra effort on our side. And once that's done, we're going to see what everything looks like. OK, so let's jump over and do some coding. OK, can you guys see that all right? OK, cool. So I'm working with the census data here. And the goal here is to predict whether a record or a person is going to make over 50K or under 50K. And the way that this library is set up is you tell it where the ModelDB instance lives or the Verta instance lives. You can set up a project here. You can set up an experiment. And if you can't see everything there, come to our booth again, and we'll show a more detailed example. Then I'm going to go and I am going to run a few models. So here I am going to create a train and test split. I have a bunch of hyperparameters I want to loop through. This could be a grid search type of situation. I'm going to build a pretty simple linear model, so it's a logistic model. I'm going to compute the accuracy, and then I'm going to go and log that model. Again, everything is going to ModelDB. So I'm going to rerun this guy. And we'll see as it executes, we can find out how the models are doing. So popping here. OK, so here's the dashboard you see once you go to the Verta web app. Here are a few projects that I'm working on. One of the biggest advantages of having a centralized repo for models is you get organization for free. You can define your projects, you can define your experiments, and your models. We also support collaboration because we found that to be pretty key because data science is not being done in silos. So we go in, and we see here that it has finished and also thrown an error. That's OK. Other people are trying to hit the same URL, so that's all right. OK, so if we jump on here, these are all the runs that I've created for this project. If you see there's about 5, I had applied a filter, so let me remove that. I've built about 30 models for this particular project. Every time that I log a model from the Jupyter notebook, it's going to go and it's going to live on the server. It can be visualized here. You can drill down. So let's jump to charts. You can look at all the models that I've built so far. What is their accuracy? Over time, are my models actually getting better? Or like, should I be trying something different? You can also look at, down here, you can build custom charts. Maybe I care about how the maximum number of iterations affects my validation accuracy. I can plot averages, sums, medians, whatever is most appropriate. Jumping back here, suppose I only cared about the experiment runs or models where my accuracy was pretty high. So I'm going to say I only care about the things where my accuracy is over 0.8. OK, I only got 5, not bad. I can also further drill down and look at things that are only for CondaCon. So all 5 of them were. All right, hooray. So at this point, we have logged a few models into ModelDB. We have visualized them through the dashboard. And we've done some basic analyses. Let's jump to the deployment phase. Usually, this takes a while where you hand off the model to your IT department or to your software engineers. They're going to re-implement it in SAS or Java or whatever is most appropriate. We think that it should be a lot easier. It should be a one-click deploy. I have stored all the information about this model in ModelDB, like what data set was used, what was the model binary, any dependencies. So I'm just going to go here. I'm going to say I want logging. If something goes wrong, I want to know what went on. I want service monitoring, which is how many requests were made, what was the latency, is my input and output data looking the way that I expect it to. So I'm going to go ahead and click Launch Deploy. It's already live. We have packaged it. We have made a REST API available. And I can go use it at this endpoint. So before I go there and show an example of how to use it, I'm going to show what a model that's live is supposed to look like. So here's a run that I'd started earlier. So we can shut that. OK, something's wrong with my mouse. Never mind. OK, so I can just go over here. Here's the model that I'd built earlier, and it's live. We're making queries to this guy every one query a second. And you can see that these charts will get updated as we keep making queries. This one is showing what the latency was like. We're also showing the throughput, so how many queries were made every second. Down here, we're plotting for every feature that your model used, how does the training data compare with the test data? So this is for age. You could be doing this for any of the features you had. Here we see that more or less our features are consistent with what we expected. So that's all fine and good. Popping back here for a second, I want to note that the only things that we logged about the model were, here's my model pickle file, here's my requirements file, and something we call an API that's used within our packaging system to enable logging, to enable monitoring. So all I did as a data scientist was add those logging statements. And what I got for free is I can get an easy dashboard. I can deploy things. I can also monitor them. And I have full control over how and when my models are getting into production. So that's a very quick overview. Let me show quickly how you can make requests against this particular model. So here's a model. Let's go and pick the model that we actually deployed. I'm going to pick that one. I'm going to give it the ID, and I'm going to make a quick prediction. So like, I'm making a REST call, and it's telling me that for this particular piece of data, this person would have like the probability of greater than 50 is 0. And then I can actually go ahead and make a lot of requests in real time that we should be able to see here. So now it's getting the data that I just started on my notebook. And we can see all of these charts. I believe you will see them update every second. So I'll leave that on there for just a minute. It's like with very little effort, we've done a few things. We have trained a few models. We have logged them in the central place so others can use them. We have deployed a model. We have inserted monitoring logic in there. We're also monitoring it. We've made some queries. This is more than what I do in a day. I don't know about you. But we were able to do this in just a few minutes. And that's pretty powerful as we want to iterate on models faster and put them into production. All right. So let me jump back to my slides. So here's the thing that we built. Created models, versioned them, ran some meta-analyses, deployed, monitored, and got a bird's eye view of models. OK, so hopefully that's of interest and pretty cool. There are a few things that we are looking to do as a company. The first thing is we think model lifecycle management is a pretty key framework that we need to adopt and make our own so that data science can actually have the impact that it should. We do various webinars and white papers. Feel free to subscribe there. Our big thing is we want to get more people thinking about these topics, thinking about reproducibility, reuse, time to delivery, and visibility and reliability. So like, come chat with us about your data science and ML workflows. We're data scientists ourselves, so have felt all of this pain and would love to pick your brain on how you do things and how can we as a community do better on all of these fronts. If some of the tools that I show right now were intriguing, ModelDB is entirely open source. You can get it on GitHub. If you're on Kubeflow, you can install it on Kubeflow. We also offer this as a managed service, and that's the email that you can reach out at for more info. On the Verta side, our goal is to help companies take ML models to production. So we're running this limited early access program where we're collaborating with companies to take one ML model into production. And our sort of promise is that in 12 weeks, we'll pick up the model at whatever state it's at. We will build the data tooling you need, and the deployment using Verta to get something up and running quickly for whatever use case is appropriate. And then there's, of course, a bunch of us here who are up at the front. We'll be working to make that happen. OK. And check out our booth. We have pretty cool T-shirts that say models are the new code. OK. To wrap up, here are the key takeaways that I mentioned earlier. We think that as we put more data science and ML into production, we should be thinking about reproducibility, reuse, time to delivery, and reliability. We find that model lifecycle management and the practices that it espouses are the way to do this. And having good tools, whether it's ModelDB, Verta, or something that you guys have built in-house, are the way to implement lifecycle management at scale and reliably. So that's all I got. I'm Manasi. Thanks very much for your attention. And I would love to take questions. We have team members here who would be happy to demo and also take questions.